Welcome to the next video. In the previous video, we have seen the pressure-based segregated algorithm. Now we will be discussing about pressure-based coupled algorithm, right? So I mentioned you the first and the foremost, the first and the foremost task in this procedure of this algorithm is to consider the updated properties. Okay, like for example, we have considered depending on the boundary conditions, depending on the material which we are using. Okay, depending on the material properties, Fluent automatically guesses some values and those are updated at first. Those are nothing but the updated properties, we can call them, right? After that, what's happening is based on these updated values or updated properties, we said that we are solving the momentum equation at first, right? Because this is a segregated algorithm, we are solving the equations one after another. But in the coupled algorithm, what are we doing is we are solving all the governing equations together. Okay, that means we are solving the momentum equation and the pressure correction equation together in one go. That is the reason it is named as coupled algorithm. Okay, let us just try to read about it. Unlike the segregated algorithm described above, the pressure-based coupled algorithm solves coupled system of equations comprising the momentum equation and the pressure-based continuity equation, right? As I mentioned you that this is not a segregated algorithm. So in this algorithm, we are not solving them one after other, but we are solving them together. We are solving the Navier-Stokes equations together. That is nothing but the momentum and the continuity equation together, or to be specific, pressure-based continuity equation. All right. Thus, in the coupled algorithm, step 2 and 3 in the segregated solution algorithm are replaced by a single step. So these two steps what we have, that is this one, okay, and this equation are replaced with a single step because we are combining and we are combining them and solving them together in a coupled manner. All right. Now what is the next point? Thus it is named as a coupled algorithm, and we are segregating and we are replacing with single step. We already discussed about this. The remaining equations are solved in a decoupled fashion as in the segregated algorithm. All right, so what did I mention in the segregated algorithm? We are solving the momentum equation, then we are solving the pressure correction equation, and based on this solution we are updating the properties again, right? But here we are solving them together and then we are updating the properties. After this, we are solving the governing the energy equation or any other scalar equations which are involved into the model. And this is exactly the similar in case of the first type of algorithm, that is nothing but the segregated algorithm, right? So after these two equations are computed, then only we are updating the values and solving the next set of equations, that is energy, species, turbulence, etc. Same case is over here. We are just combining them and solving, updating the properties, and then solving the additional equations in the model. Now after solving the equations, we are checking whether the numerical values for the momentum, the continuity, and the additional equations, the numerical values of all these equations is below the benchmark value or no. If it is less than the benchmark value, then the solution is converged. If it is not, then if it is not less than the converged, if it is not less than the benchmark value, then we have to restart from the first of this flowchart. Okay, then whatever updated properties we had, these values will be shifted over here. Okay, and then we will be solving these equations in a coupled manner. Then again we will be getting some new updated values. We are updating the solution and then we are solving the additional equations, checking whether the values are below the benchmark value or no. Clear? Now this is what is the iterative process. Now let us just continue the next para, and it is written over here that since the momentum and continuity equations are solved in a closely coupled manner, the rate of solution convergence significantly improves when compared to the segregated algorithm. I mentioned you that the convergence time for the segregated algorithm is a little bit higher because we are solving the equations in a segregated way. That means we are solving them one after the another, right? So this requires a lot of time for us, and therefore the convergence will happen a bit later. Okay, a bit late we can say. Whereas in the coupled algorithm, since we are solving them together, we are able to achieve convergence in a quick manner. Okay, and but there is a downside for this, that is the memory requirement increases approximately 1.5 to 2 times that of the segregated algorithm. So as we are solving them together. There are a lot of equations. The momentum equation will have, if you're solving a three-dimensional flow, you'll be having the momentum equation in three directions, that is u, v and w, right? Then we will be having the pressure-based continuity equations. So what is happening is, because of the overload, you can just say in simple language, because of the overload, your memory requirement, it requires a lot of RAM memory, and the amount of memory requirement will increase two times, approximately 2 times or 1.5 times the segregated algorithm at I'm sorry, it requires 1.5 to 2 times that of segregated algorithm. All right, so this is what is mentioned over here. It is not a big thing, and this is because the discrete system of momentum and energy continuity pressure based continuity equations need to be stored in the memory when we are solving the pressure, velocity and pressure fields, rather than just a single equation as in the case of segregated algorithm. That is what is mentioned over here, and I believe you have understood the differences between the two algorithms in the pressure based numerical method. So on a quick revision, I mentioned to you that the Fluent solver has two numerical methods. The first one is called as the pressure based numerical method, which is broadly used for cases where we are having a slower speed regime, okay? And the pressure based solver is having two algorithms. The first algorithm is the segregated algorithm, and the next one is the coupled algorithm. In the segregated algorithm, we are solving the governing equations in a segregated manner, which is nothing but one after another. In a coupled algorithm, we are solving them together, and this increases the memory requirement, whereas this doesn't require a huge memory for us. But the point is, the convergence time for segregated algorithm will be higher, whereas the coupled algorithm, the convergence time in this case will be lower in comparison to the first one. The next type of numerical method is the density based numerical method, whose theory we will be discussing in the next video. So let us move to the next video.